Algorithms run faster in hardware than in software. How can such an algorithm be modeled in VHDL? Hello and welcome to this tutorial about sequential modeling in VHDL. Often, algorithms have to be processed sequentially and cannot be fully implemented in parallel way. To cope with this, VHDL provides processes. This statement defines an independent sequential process representing the behavior of some portion of the design. It consists of sequential statements whose execution is made in order defined by the user. VHDL allows to use multiple processes in an architecture. In this case, the processes are executed in parallel. Usually, we want the processes to run in case of an event, more precisely, a signal value change in the system. For example, if we use multiple processes in parallel, we might want them to be triggered at the same time to run them synchronously. To achieve such a behavior, we can make use of the sensitivity list. Let's have a look at a simple example to get an idea of how a sensitivity list is implemented. As you can see, I already set up a simple entity definition and an empty architecture. To use a process, we first name the process and then use the process keyword. After this keyword, we can define the sensitivity list, putting the relevant signals inside the parentheses. In this case, we want to model an AND gate. Hence, we have to put all input signals into our sensitivity list. Now we can define the behavior of the process after using the begin statement, which is fairly easy in this case. Let's have a look at another example. This architecture also describes an adder. However, the results of the AND operation is first assigned to a new signal called temp. The value of this signal is then assigned to our output signal O. Will this change the behavior of our model? In this case, yes. But why? In VHDL, the value of a signal is updated at the end of the process. Consequently, when assigning temp to O, temp still holds the results before the AND operation took place. However, if this is required, VHDL provides variables. These are immediately assigned but can only be used inside a process. To distinguish between both types, there also exists a dedicated assignment operator for variables. Let's come back to our previous example. We now want to use a variable for the result of the AND operation. Therefore, we first have to define a variable before the beginning of the corresponding process. Instead of signal, we just use the keyword variable and give it an arbitrary name as well as a type. Now we can update the architecture using the variable. Therefore, we have to use the special assignment operator, as you can see here. Finally, we can assign the value of the variable to our output signal, and that's it. To sum it all up, with processes in VHDL, we can model sequential behavior in our design. Consequently, with this in mind, you can implement algorithms as we know them from software applications and let the tools synthesize it onto your target hardware platform.